In this video, we'll go through the thought process of how to diagnose cooling fan circuit problems. We'll show some quick roadside tests that will help to narrow down the search. And we'll go into a real-world repair of a Kawasaki Vulcan that overheats in heavy traffic.
Good morning. Well, I had an interesting thing happen to me last week. Let me tell you the story. I was on my way to a sailboat race, and I ended up in stop-and-go traffic, just frustrating to be just bumper to bumper, going about 1 mile an hour. And I looked down at this little idiot light right here, and the overheat light was on. And so quickly I found an exit. Fortunately, it was a downhill exit, so I rolled the bike down and turned it off as I was coasting to a stop in front of this lady's driveway. There was no problem with the engine at all. It sounded fine. It wasn't steaming up or obviously overheating, but I had to get it off. So I had the engine off, but the key was on, and I noticed a critical clue. It's right here. Do you see that? That's the fan right there. Now when you're overheating, that fan should definitely be on. And those blades were stationary, even though I can move the fan easily. What's the diagnosis? Now the second thing I noticed is there wasn't any coolant or steam escaping from the upper radiator cap area. And at the level of the reservoir, you can see right there that fluid level is pretty much normal. It wasn't bubbling at all. So at that point, I called for a ride and thought about the diagnosis as we were going to the sailboat race. And I reasoned it was probably fairly secure that we've got a cooling fan issue. And so after the sailboat race was over, I got someone to follow me back to the bike, and carefully I drove the bike all the way home in the cool of night with no traffic. And I was certainly ready to pull the bike over and turn it off again if it overheated again, but it didn't do that. In the cool of night with a steady breeze as the bike was making headway, I got right home with no problem. The next morning I stopped to have a look at it. Okay, I've got the camera sitting on the right-sided brake pedal looking up so you can see the two coolant sensors on this bike. The first one is right there, and that's called the coolant temp sensor. It's a single wire device. It's normally open, and when the temperature reaches 113 degrees C, it closes to turn the idiot light on the dash on. Now the second sensor is called the radiator fan switch, and that's this thing right here. And there are two wires to it. And it turns, it's normally open as well, and the switch closes at 95 degrees C. So if the bike is hot enough to close this one, it should certainly be hot enough to close that one. Is this switch working properly? The circuit is really simple. This is the battery here, and power comes out the battery through the main fuse to the ignition switch. And we know both of those are normal because the bike runs. From there it goes to the fuse box. And initially I was going to test here, but it's a bit tricky to get to in the Vulcan, so we're going to pass it over and test it further downstream. This is the radiator fan switch, and it's the one in concern. And then from this fan switch, power goes to the motor and then back to the battery. Don't worry about this. This is not a diode. This is just a connector in Kawasaki terminology. The easiest place to access this circuit is right here at the two arms coming into the radiator fan switch. Let's do that testing now. Now, by far the best way to learn this material is to think it through yourself. The problem could be in the fuse, the wiring, the switch, or the motor. And I've told you where we're going to test it. Now what I want you to do is I want you to pause the video and think through what you would do next. As a springboard to that thought process, I'm going to give you 4 options. I'm going to ask you a question, give you 4 options, and I want you to think through which tool will give you the quickest form of diagnosis. Which tool is going to get you the diagnosis fastest? Pause the video now and get back to me. Well, I had to pause the video while my dog was puking, but anyway, we'll get back to that problem later. So I've posted multiple videos through the years of how to investigate motors with all of the tools that you've looked at there. And so this is really not a question of which tool is better. It's more a question of, given the context of what we're dealing with and where we're testing, what's the simplest tool to come to a diagnosis? Now, the multimeter is an old standby, but the biggest problem with the multimeter is that it's got such huge impedance that it's very difficult to detect upstream or downstream resistance when the impedance is 10 million ohms. And so the multimeter is generally considered a poor choice. The second option is a test light, and I normally love the test light because you can use it as a substituted load. Even if the motor is not working, you put it into a circuit or you can isolate a section of wire and see if there's any significant resistance there. And if you choose a test light with the correct amperage draw, roughly the same as what your motor most of the time, you'll end up with a result that's easy to interpret just with a simple light going off. The problem with that is that in this situation, the point that we're testing at is in series with the motor. And so if you put a test light there, you get a voltage drop with the test light and then a voltage drop in the motor. And you wouldn't know
whether that's influencing the result you get. You could get the motor turning on, you can get the test light turning on, you can get both turning on or both turning off, even with current flowing. So you get a result that you can't really interpret. The third option I put there is the oscilloscope, and you can use an oscilloscope to test motors, but generally speaking, that's probably not necessary. That's using something very sophisticated for something that you really don't need to do. If the motor was intermittently failing, that would be a useful option, or if you thought the current draw was too high, if the fuse was blowing. But in this situation, the best option is option 4, the lowly jumper wire, the low-tech option, something you could actually do at the roadside. That's the best way to approach this now. Let's do that now. All right, let's see if I can work around the camera here. First thing I'm going to do is to unhook these 2 wires. They just press on. And now, remember you have to have the key on, but I've just got a simple jumper wire here. I'm going to jumper the 2 sides, and I want you to listen for the fan to come on. See that? Woo-hoo! I don't know if you can see, I'll turn it off. Well, isn't that cool? Just with something worth a few pennies, we were able to prove that it's not the fuse, it's not the wiring, it's not even the motor, and so the only thing left is the switch. Now, could I be wrong? Is there something that could be wrong here? Well, the one thing that's really hard to exclude is an intermittent from, say, a failing motor where the brushes are wearing and it gets to a bad spot and suddenly it won't work. And it's hard to exclude that, but just on the basis of probability, I think that's unlikely enough that I'm going to go ahead and order a new switch while waiting. Now, in your situation, that may not be the case. You may find that you're not uncertain of the diagnosis, or you didn't have that critical piece of information, in which case you want to test that switch and prove that it's bad. And I'll show you how to do that at the end of the video. For now, let's get going and put in a new switch. So we have to drain the coolant off to get that switch out, and so I've got this yellow thing here to drain it. Now, under the vehicle, that's the front of the vehicle. Here's the starter motor. Here's the oil drain plug, and this is the 10mm coolant drain plug. We're going to drain it from right there. Remember, the cap of the radiator has to be off, otherwise you're not going to get any coolant coming out of here. So I'm going to move the camera out of the way, use this 10mm wrench, and just spin that off. This is 6mm. You just need this one here, not the other 2. And then you slide it forward, and it won't come off completely unless you remove this thing, but we don't need to do that. I just want to get at this radiator cap right here. Now that it's cool, I can safely take it off. Often you have to push these down to get them off. Oh yeah, there we are. And if it won't come off completely, just push down some more and then it comes off. And you can see right in there, there's the thermostat, and the coolant level is right at the level that we want it to be. So there's no loss of coolant, no air pockets that we can see. Now this switch has got some kind of a rubber condom on the top of it, so I'm going to try and pry that thing off. The new switch doesn't come with a rubber cover, so I'm going to try and save it if I can. I don't tear the heck out of it. There. There's that. Now, ideally I'd like to put a socket on here, but I don't want to have to remove the gas tank, and so I'm going to use an open-end wrench. This is 27mm. Don't know if I can do this with the camera in the way, but oh yeah, that's not very tight at all. You see it has an O-ring there that gives the seal. So you don't need any tape on it because the O-ring is responsible for the whole seal. Okay, here's the old sensor and the new sensor. And that's the OEM Kawasaki part number right there. Let's open it up and compare the two. Pretty much identical. Okay, so the nightmare here would be to cross-thread it. So be really careful. This is aluminum, I think. So you don't want to cross-thread this baby. And there is a torque spec to it, but I don't have a torque wrench that goes with an open-end wrench, so I'm just going to go to
there. That's good enough. Now it's time to put more coolant in right there, and this thing is getting in my way, so I'm just going to take it off. You just have to undo the speedometer cable here, and then there's 2 electrical connectors, and then this whole thing comes off. So there, one, and then the other one. You see that? I got to get that hook down. There. This whole thing lifts off. So I've got one of these no-spill funnels, but the fit on the Vulcan isn't all that great. So I'm just going to use it as a funnel, as a regular funnel here. And carefully add the fluid, try not to make a mess. This is what I'm using. Now, because that was concentrate I'm using, I'm going to add in some distilled water. Should be about 50-50. The mix doesn't have to be perfect in our climate. This is a page from the dealer's repair manual focused on testing the radiator fan switch. You can pause the video and read it if you need to. I added salt to the water so the boiling point would be higher, but even at top boiling point, my old sensor clearly failed and the resistance reading didn't significantly fall at all. Okay, so one question that might occur to you is, with this little strip we were able to hotwire the fan. Why couldn't you, in the situation of being a long ways from civilization, maybe just doing that to try and get yourself home? And indeed, you could do that, but a couple of points of caution. First off is, there's a major risk here, and so you better be 100% sure of your diagnosis before you do something like that. And then secondly, newer bikes are built on a thermistor model rather than bimetal strips, and the thermistor PCM situation is quite different, and so that doesn't necessarily apply with the newer bikes. I hope I earned your like today. I'd love to hear what anybody thinks. Thanks for watching.